Hey there, how's it going everybody? In this video, I wanted to walk through some real-world examples for how we can calculate the number of days or months that it will take to reach certain goals. So we just went through the New Year holiday, and maybe some people have some goals that they'd like to accomplish. So whether that's, paying off some credit cards or getting in better shape, or personally for my YouTube channel, I'd like to reach a certain number of subscribers and just things like that. So I thought it might be fun if we could write a program that will give us an estimate of how long it will take to reach these goals. And writing scripts to solve problems like this is a great way to take certain things that you've learned and apply it to real-world examples. So in this video, we'll write a script for all three of the examples that I just mentioned. And all three of these examples will be slightly different so that we can see how we can write quick little scripts to solve three different specific problems. So one is going to be a script where we make monthly progress towards a goal. One will be a script where we make weekly progress towards a goal. And one will be a script where we make daily progress towards a goal. So first, let's start with writing a script to calculate the number of months that it would take to pay off a credit card. And this will actually be the longest script that we write, and the other two will be shorter and shorter. So let's go ahead and get started. So I have a script opened up here, and you can see that I've already imported the modules that we'll be using. So I've imported the date time module and the calendar module, and we'll see how we use these in just a bit. Okay, so first of all, let's figure out what our constants are going to be for paying off a credit card. So first we have the credit card balance. So I'll just set that a variable as balance. And for now, we'll just set that to $5,000, for example. And we're also going to have the interest rate. And I will set that to 13%. Now you can do this as a decimal, or you can just write out 13 and multiply that by 0.01 to turn it into a decimal. So for example, in this instance, we want the interest rate of 13 to actually be equal to 0.13. Okay, and another constant that we're going to be working with here is the monthly payment that we're going to be making towards our credit card. So we'll say monthly payment, and for now we'll just set this equal to 500. So these are just all sample values that I'm plugging in right now. And we can change this after the script is written to see what different results we get. Okay, so now that we have this information, let's think about how we can write a script that uses this information to pay off our credit card. Well, when we pay off a credit card, we usually make payments on the first of the month or towards the end of the month. So some people do it on different days, but you can change it depending on how yours is set up. So what I'm thinking is that we can just assume that we'll start making our first monthly payment starting next month and see how long it will take us to pay off our credit card with the interest building up. So we're going to need to specify some dates. So in this example, I'll start from the current day. So I'll set that as a variable just by saying today is equal to, and that's going to be equal to datetime.date.today. So that is how you get the current day. And now we need to figure out when it will be the first day of the next month. And this is one of those things that seems like it would be easy at first glance, but after you think about it for a while, it actually is a little tricky. Now, there might be some better ways of doing this, but if we want to set a variable that is the first day of the next month, then let's just take the remaining days left in the current month and add those to the current day. So to do this, we'll need to know how many days are in each month. And to get this, we can use the calendar module from the standard library. So it has a method called monthRange that takes a year and a month as arguments and returns the first day of that month and also the number of days in that month. And it also works for leap years too, so it's good for any year. So we can say days in current month, and we will set this equal to calendar dot, and that is the month range function. And now this takes in a year and a day. So we want to get the number of days in the current month. So we'll just say today dot year, and the second argument will be today dot month. So given this year and month, this is going to return a tuple with the day of the week that the first of that month falls on, and also how many days are in that month. So if we print this out, so I will print out the days in the current month, save that and run it. So the first value here is the day of the week that the first of that month falls on. So the first of the month is, I think 0 is Monday. So that's going to be a Monday. And the second value here is the total days in the month. And that's the value that we want. So I'm going to grab that just by getting the first index of that value. So here at the end, I'm going to tack on an index of 1. So now if we save that and run it, you can see we're just getting the days in the month. So now if we wanted to advance to the first of the next month, then we could just add the difference of the days that are left. So we can create another variable here, and we'll just call this days, days until end of the month, and we'll set that equal to the days in the current month minus today dot day. So now if I print this out really quick, then at the time I'm recording this, it is the 16th, so it should do 31 minus 16, so 15. So it's saying that there's 15 days until we reach the end of the month. Okay, so now we have the number of days that we need to add to the current day in order to carry us over into the next month. And to add days to a date, we can use a time delta. So let's see what this looks like. So I'm going to create a start date variable here because the first of the next month is when we want to start making our payments. So we'll say start date is equal to today and plus datetime dot time delta. And now we're going to pass in a number of days that we want to add to the current date. So we'll say days are equal to days till the end of the month. Now that is just going to take us to the end of the month, but we want to start on the first. So now we will just add 1 day onto that as well. And just to make sure that worked, let's print out this start date. So I will save that and run it. And you can see that we do get February 1st, which is the first of next month since I'm recording this in January of 2018. Now, if any of this is confusing to you so far, then I do have a video on the date time module where I go in depth about all of this stuff. But for this video, we're just applying those concepts and kind of moving through kind of quickly here. So I'm not going to go into as much detail about adding dates and things like that. But if you are interested, then definitely check out that date time video. Okay, so now we have the first day of the next month. Now, I don't want to change this start date variable because we want to reference that later. So I'm going to create another variable here called end date. And for now, we're just going to set this equal to the start date, but we will be incrementing that end date throughout the script. Okay, so now we're ready to see how long it will take to pay off our balance. So let's create a while loop that just says while our balance is greater than 0. So every time through this loop, we'll simulate the beginning of a new month. So first we need to add the interest that has accumulated from the previous month. So since these interest rates are usually annual, we need to divide it by 12 to get the monthly value. So then we can multiply that with our balance to get the total interest charge. So we can say interest charge is equal to, and that's going to be equal to our interest rate, which is usually annual. So we need to divide that by 12. And once we have that interest rate divided by 12, then we can multiply that by our current balance to get the total interest for that month. So then that total interest charge is going to be added to our balance. So we can say balance is plus equals the interest charge. Now this plus equals operator here is just the same as saying balance is equal to balance plus the interest charge, but it is just cleaner and a little bit better to do it that way. So we'll do plus equals interest charge. And now since we're simulating the first of the month here, we also want to subtract the monthly payment that we're going to be making from our balance. So we will also say balance minus equals the monthly payment. So what we've done so far here in our simulated first of the month, we've calculated the interest charge, we've added that interest charge to our balance, and we've also subtracted our monthly payment from that balance. Now, since we've been modifying this balance, sometimes floating points can get a little off and we can have a lot of decimal places. And since we're working with, some simulated money here, let's round our balance to 2 decimal places just so it looks like, cents. So we can say balance is equal to, and round is just a built-in function, and we can do round that balance to 2, and that'll round it to 2 decimal places. And also there's a possibility that we will pay off our balance. And if we pay off our balance, then we don't want our balance to be in the negative. We just want it to hit 0 when we pay it all off. So let's say if the balance is less than 0, then just set that balance equal to 0. Now, we could have actually taken these 3 lines here and made them into a one-liner with a ternary conditional. Now, if you don't know what that is, basically allows us to set a value based on a conditional on one line. So I could have said, instead of these 3 lines here, we could have said that the balance is equal to 0 if balance is less than 0, else balance, or else round the balance to 2 decimal places. Now, some of you may have never seen these before, so just again, this is setting the balance equal to 0 if our balance is less than 0. If it's not less than 0, then it's just going to set balance equal to our rounded balance to 2 decimal places. Now, some people really like these, but I always like to err on the side of being more clear than writing less code. So I'm just going to do mine the way that we had it up here, because I think it's a little bit easier to understand exactly what's going on. Okay, so at this point, we've done everything that we need to do for this month and are ready to increment to the next month if the balance hasn't reached 0 yet. So at this point, let's go ahead and print out our end date and the remaining balance. So I'll do a print of the end date and the balance. And after that, we want to increment our end date variable forward another month before we continue on with the next iteration in the loop. Now, to move forward a month, we can just add the number of days in the month to our end date because we already know we're on the first day of the month since we took care of that before. So there's no need to get the remaining days like we did up at the top of our script. So let me scroll up to the top here and we will reuse a lot of this. So let's see, I will grab these 3 lines here and paste these in, and then let me correct the indentations here. Okay, so like I said, there's no need to calculate the days till the end of the month because we already know that we are on the 1st. And now the days in the current month, instead of these values that we used before, we want to use the end date.year and the end date.month and still get that first index, which will give us the rest of the days in the month. And now we want to set this end date variable equal to the current end date plus the number of days in that current month. And we don't need this +1 anymore. So I can save that. Okay, and if you're still not quite sure what this is doing, basically let's use February as an example here. So after this does all these things here for the month of February, then it's going to come in and say, okay, get the number of days in February. So this is going to be equal to 28. And then basically here we're just saying, okay, now add 28 days. And that's going to carry us over into March. And then it's going to continue this pattern every time we go through the loop. Now, at this point, this should be all that we need to do. This while loop will keep looping through and calculating our interest and balance after we make our payments, and then incrementing over to the next month. Now, you have to be careful anytime you use a while loop because there's always a chance that you could get stuck in an infinite loop. So, for example, if we were to be making monthly payments that were less than the interest that was being added on every month, then we would never pay off our balance and we would never exit this loop. So you definitely have to watch out for that. Okay, so now let's save this and run our code and see what we get. Okay, so let's scroll up here to the top of this to see our constants, and also let's expand this a little bit. Okay, so we can see that if we have a balance of $5,000 with this interest rate of 13% and started making payments of $500 every month, then our output shows that what our balance, new balance would be at the end of each month. And our balance hits 0 down here on December 1st of 2018. And you can play with these values in any way to see what results you would get. So if you want to, pay off a $10,000 balance with, making payments of $400 instead, then you can see that that doesn't get paid off until 2020. Now, if you were to make a really low monthly payment, so let's say like $110, you have to be careful not to do less than the interest that's added, like I said before, or else you'll get in an infinite loop. But if I run that, then we can see with payments that small that we don't pay off our balance until 2050. And the reason that that is so slow is because our monthly payment barely pays the interest each month. So if we scroll up here to the top, then you can see that we only paid off, $2 from our overall balance in the first month, and everything else just went to interest. Okay, so that is a pretty interesting script that you can use to estimate how long it will take to pay off a credit card balance. So now let's move on to our next script. And so let's say for this script that we want to write a script that will, if we wanted to get in better shape, how many weeks it will take us to lose a certain number of pounds. So I have an empty script here where I already have my imports, and you can see that here I'm just importing the datetime module. And like I said, this script is going to be a little bit more simple than the one that we just wrote. Okay, so just like our other script, let's start off with a few constants. So first, let's put the current weight and then the goal weight. So for example, let's say that someone is 220 pounds. Sorry, I'm using pounds instead of kilograms. If you want to do those conversions, you can do that. Okay, so I'm going to say current weight is equal to 220 pounds. And let's say that we have a goal weight, and let's just set our goal weight equal to 180 pounds. And now let's do an average pounds per week that we plan on losing. So I'll say average LBS per week. And usually people recommend, to safely, if you're losing weight, that you can safely do that by losing 1 to 2 pounds per week. So let's just do right in the middle at 1.5, 1.5 pounds per week. Okay, and now we need a start date for when we plan to start. So let's just do this for today. So we can do a start date, just like before, that is datetime.date.today. And just like our other script, we want to keep this start date variable unchanged. So let's set an end date variable as well. And for now, we'll just set this equal to the start date. So now we have the information that we need to go ahead and make our loop to simulate losing our average pounds per week until we reach our goal. So let's start our loop. So our loop can be while our current weight is greater than our goal weight, then let's keep going through this loop. So within our loop, we can simulate 7 days going by. So to do that, we can say that our end date plus equals, and now we want to add 7 days to our end date. So we can do that with datetime.time delta, and then the number of days. We can say days equal to 7. And after those 7 days have gone by, we can say that our current weight minus equals, so we're going to subtract our average pounds per week. So basically what we're saying here, each time this goes through this loop, it's going to say, okay, we are adding 7 days, 7 days have gone by, and our current weight is now our average pounds per week less. And it's going to keep doing that over and over until our current weight is no longer greater than our goal weight. Okay, so outside of the loop, let's print some information about how long that took. So for example, let's print the number of weeks. So I can do a print here, and I'm going to use an F string. Now, F strings are only available in Python 3.6 and above. If you're using a lower version, then you'll have to use, a dot format or something like that. But within our F string, I'm just going to say reached goal in, and then we can put in our placeholder here, and we will just do an end date minus start date. Now, when we do an end date minus start date, that is going to give us a time delta. And time deltas have a days attribute to where we can see the total number of days between these two dates. So now we have the total number of days between those two dates, but we want to see how many weeks have gone by. So now let's do a division by 7. Now that is a floor division to where it will cut off decimal places. And then outside of our placeholder, we can just say weeks. So let's see if this works. So if I save this and run it, then we can see here that it prints out that we reached our goal in 27 weeks. Now, if we actually want to know around what time that is in the year, then let's actually just print out the end date above here to print out that exact date. So now if we save that and run it, then we can see that with our current weight and goal weight and average pounds per week, that we met our goal around the end of July, which was 27 weeks. Now, we can come up and change some of these constants to see what changes with our script. So if we kept the same current weight and goal weight, but bumped our average pounds per week up to 2 and then reran this, then we can see that now that is 20 weeks, and we got there in early June. Okay, so you can see that this script was only about 15 lines, pretty easy and just kind of fun to play around with these values and see what you can get. Okay, so now let's look at one more example, and this example will be even simpler than our other two scripts so far. So let's say that I had a goal on my YouTube channel to hit a certain number of subscribers here on YouTube and would like to see how long it will take to reach that goal. So I have another blank script here where I'm importing the date, time, and the math module. And just like with our other two scripts, let's start off with some constants. So in our credit card example, we were writing a script where we were making progress every month. And in the weight example, we were writing a script where we were making progress every week. And in this example, we're going to see what it looks like to make progress every day. And like I said, this is going to be the simplest one. So first of all, let's start out with some constants here. So let's say let's set what our goal is. So let's say the goal subs is 100,000 and the current subs, let's see, I think that is around 85,000 right now. So now another constant, let's just say subs to go is equal to our goal subs minus our current subs. Now, these aren't exact numbers. We're just kind of using these for this script. So now let's set at what our average is per day. How much progress are we making per day? So let's say that the average subs per day is equal to 200. So now that we know how many we have to go and how many we're getting each day, now we can just divide how much there is to go by the number that we're getting per day to get how many days that is going to be. So we can say days to go is equal to the subs to go divided by our average per day. Now this is likely going to return a floating point number, but since we want to work with whole days, let's just take the ceiling of this value here. So that is what I imported the math module for. So we'll say math.ceil and pass in those values into the ceil function. So basically what that does is it just rounds up. So if this value was equal to, 150.4, then it's just going to round that up to the next value. So with an easy script like this, we can just add the days to go to the current day and we'll have our estimate. So I can say today is equal to datetime.date.today, and then we can just print out our answer here. So I can print out today plus datetime.time delta, and we want to add the days to go. So we'll say days is equal to days to go. So this will print out how many days into the future we meet our goal. So in less than 15 lines of code, we write something that can estimate something like this. So if I save that and run it, then we can see with somebody who has 85,000 subscribers trying to reach 100,000 subscribers at an average of 200 per day that they will reach their goal around April 1st. So maybe a better goal if you were going for the entire year would be something like 150,000 if you save that and run it. Then you can see that you would meet that goal around the beginning of December. So it's kind of fun just to write these short little scripts and to be able to play around with the numbers just to see what you can get. And you can always make these scripts more complicated if you'd like. So maybe with this script, you'd like to add in something like, expected monthly growth or something along those lines to make your estimates more accurate. Or with our credit card example, you could add, expected monthly charges or something like that. But hopefully these 3 scripts gave you some ideas for how to get started if you'd like to do something like that. Okay, so I think that is going to do it for this video. Now, we didn't really cover any new topics that we haven't seen in other videos, but applying what we've learned to quick real-world scripts like this is a great way to take what you've learned and write something that could be useful for yourself or someone else. And just taking the time to try to solve these problems is great practice. And there are a ton of different ways that we could have written these scripts or added more to them. So like I said before, we could have added more complexity if you'd like. We could have also taken this logic and put them into functions so that we could reuse the code in other modules. So there is a lot that you could add to it. And if you'd like some additional practice, then you can take what we've written here and try to add to it, or you could even try to clean it up a bit. But if anyone has any questions about what we covered in this video, then feel free to ask in the comments section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.